day. Good day, thank you for coming. And in this talk, let me unlock the laptop first. Looks good. Let's spend this talk on a user space. We already got from yesterday Ivan's talk, for example, how the way from the UEFI to the driver to the user space could be built. In this talk, we would talk about user space, because to my experience, mostly last stages, all the main payload, living over there. All preliminary tasks are about the anti-detection, persistence, whatever. So I'm Denis, I'm with Kaspersky, specialized on threat hunting, reversing, and in this year, I decided to propose a topic on a new place to hide fileless malware. As you understand, fileless is just, you remember NTFS, alternate data stream, right? BMI subscriptions, Windows system registry-based persistent. So it's exists on the level of a file system anyway. So it's not a fileless, but it's not as plain as a file. So security solution is not that easy to obtain this data. Let us take a look on a new way to hide the encrypted shell codes on a system. 40 minutes, it's quite an amount of time. Let's plan it a bit. But this plans on Go seems to this summer is gone already. So our plans would be a little bit different, maybe more boring, not a psychor on the beaches. So I actually, as a threat hunters, we are mostly observe in real campaigns. So this technique, it's not a proof of concept from the researcher, it's in the wild technique. Let me first, in the beginning of the talk, let me present this new, which I consider most innovative part, and after it, slowly move to the parts, to this campaign, all other auxiliary techniques, like a usage of the third-party code, commercial and non-commercial, and ways how they patched the real event logging under Windows, patching AMCI mechanism, usage a little more esoteric compilers to protect the malware from the security solutions, and so on. And to start from the how they hide shell codes into the Windows event logs, let us first cover the more typical usage of logging and shell codes in a malicious campaign. Who is analyzing malware on a daily basis in your job? I see. So I suppose in this case, you also quite familiar for you using of the logic, right? In some malicious samples, the researcher could obtain some hints from the logic. At the first glance, we could think, why? Why from the malicious author to help us with some messages like this module is already done, its job, its shell code is in place, etc., etc. So I have a theory about it. It's mostly because imagine you debug your data in some virtual environment, and after it you have to place in a combat mode, right? Many things could go wrong. So malicious developers are still the developers. They need to understand which stages of the attack went well, and at which stage it was something went wrong. I suppose that's why some logging exists. I also remember the malware samples where this login mechanism was in the future version was wiped. So they make it the version which is stable, no need to debug in a combat environment anymore, and login message is done. Also, I suppose some of them it just plays, removes the logs later in a to-do list, and it lives for years. But it's really interesting to observe how this logging mechanism is wiping out. So it's a more common usage of the logging, like in any malware. What about the shell codes actually? Shell codes is also, you could observe in your malicious samples were mostly. So the guys who are into also malware research as we are. In infected documents, right, they could be placed. So any place where some small amount of code has to be executed to initiate the following phases of the attack. Whatever, small place in the memory, some document, some vulnerability in a complicated format like a PDF, RTF, whatever. And what is special about the shellcodes, they couldn't use all the precious help from the PE or ELF file loaders, right? They are on their own, they have to implement some techniques which could make the code position independent, and that's why we observe all this stuff which you could see on the code snippet, like a call next instruction and pop in the address from the stack to understand the precise location in memory. Like a parsing of process environment block to get the real address of the API functions which shellcode is needed to execute further. And also a lot of parsing executable formats like a PE under Windows to get the next stage to put it into the memory and execute it further. So actually just small snippets of code, auxiliary mostly, as downloaders, as injectors for the following stages. Now we are covering typical usage of logging and some shellcodes, right? But here you could tell me so far, not new for us. What is new here? I like actually this engineering decision. Why not to combine these two tasks? Why not to use some kind of event logs to keep encrypted shellcode for the next stage? Actually, yes, under Windows, what main logging mechanism we have? Windows event logs, right? So you could run MMC, you could take a look at the all information or critical errors logs over there, Windows event logs. On the level of file systems, where could you find it? In a bunch of the EBTX files, right? So once again, this I already place the Fileless in some kind of brackets because it exists on the file system, but it's some very proprietary, very unclear format, and no security solution most probably would parse it. That's why some engineer from the malicious side wanted to put binary data over there. But typically, so far, we're describing logs like text messages, right? This module executed, this stage is okay, this stage failed, it's mostly text. But in case of working with the Windows event logs, actually completely legit, you could put binary data over there. It's not a problem at all. Imagine you develop some, for example, simple driver. You get your device, writing in driver, and you expect some messages from your users, and you want to understand your support server, understand what's going wrong, besides the messages in event logs. Maybe you would need some mini dumps, binary mini dumps. And operating system provide you such an ability. You could put binary data as a part of your login message, just to understand what happened while your program is executing. Why not to use in a malware software? Looks like a place, if we could save binary, this binary could be executable, right? Nobody could stop us to put over there some Intel comments. So why not? Okay, but so far I just described it in a word. Let us take a look at the code. So we are coming at this stage at a real campaign, as I promised. And here goes the module which gathers the code from the Windows event logs. So let's take a look what happens here. So if the sound, you tell me when I have to bring it here or there. What is better? Over there. Cool. Because I remember from the sitting here, I want to hear it maybe a little bit louder. So allocation of 500 kilobytes, right? After read in a new buffer, if it's a 500 kilobytes, we would be gathering what? The malware registered the event data source. Event data source is a key management system. Who remember key management system? Who is a Windows user? It's a licensing mechanism, right? If you're licensing your Microsoft Office, your operating system, KMS is the way how you let your laptop, for example, know it's a legit version of the Windows, legit version of the Microsoft Office. KMS exists. One more completely legit data source for the logging. What's next? What's next? I see reading the event logs, reading one after another, sequential. I put some comments over there, sequential read, and forward read from the very old one to the newest, sequentially, all the log messages related to the KMS, right? And some auxiliary task, if some error handling is over there, and also some reallocation if 500 kilobytes is not enough for all the data gathering from the logs, memory would be reallocated. Okay, but you could ask me, Denis, you told us KMS is legit. Here we are reading all the messages from the KMS. Why? It couldn't be the shellcode, right? It would be the normal messages from the logging system. Let's go further. Let's go further. Here goes they implement some filtering. What is once again, we're taking a look at the code in the decompiler, which I already analyzed and marked for you, all the fields of the corresponding structure. Filtering by event category, right? So all the events has the following attributes: from which event source they came, which event category they use, and which event ID they use. Event category, in this case, have to be in hex 4142. On the slide, you would see in ASCII format, it's a AB, and they knows for sure legit KMS data source wouldn't provide any log records with such a category ID. For 142, it's a custom for them. They actually, in the next version of the malware, could easily change it. The only needed property from this constant is the legit data source, event source, would not use it never. For 142 AB, would be all these messages, would be related only to the malware. After it, they use some C++ container, this time the simplest one is a std string, and appending all the messages with such a category ID to one string, just for the further take the data from the string and execute it. Okay, so already 2 slides with the code, but all of this related for the reading, right? So reading messages from event log, putting into container. But actually, who put it over there? For sure, not KMS, not Windows, right? They need some dropper. And here, on this slide, I put on your right, you see the familiar code snippet related to the reading these messages. And on the left, it's a separate model. It's actually the dropper. And dropper put it over there. So let's enumerate all the Windows API functions we need to fulfill this task. Legit Windows API. So nothing wrong with the function. You remember register event source. Let us keep W suffix. It's just let us know it's a white. All the arguments is Unicode string. Register event source and read event log, from which we would read, and some function to actually read it. But on a dropper, we need report event. And some new argument important for us, important as a IOC for the incident response in case of this malware, appeared in the argument of report event. Take a look. We already know for 142, it's a category ID, right? Filtering on this seems like on this clicker. I don't have the red point, so I would go over there. Category ID, right, the same as on our previous slide for the reading. But as well, we also get event ID and the very start location of event ID. They know precisely to which category and which incremental value they assign to the malicious event log. One more argument I want to emphasize here, it's a type of this record in your Windows event log mechanism. It would be just an information record. So you would open MMC, you would open the corresponding snippet, take a look with all the records, you would see it's a KMS, information type, and all the data over there. But by default, during my experiment, I would see the normal MMC interface wouldn't show you the binary addition to these logs. So actually, all this binary data, all this encrypted shell code, to read it, you need to some other instrument or need to write your own some tool to read the binary part of the data. Okay, dropper we are covering. What else we need? So what is actually inside? We have a dropper to put data over there. We have launcher to get the data from the event data source. But what it would execute it? Actually, inside after the decryption, nothing special. As if you analyzed sometimes some shell codes, it could be quite a familiar picture for you. It's actually the running next stage. The one thing I want to emphasize here, even through this conference, you already seen this typical hashing algorithm from the Metasploit, ROR13. So they wouldn't keep the name of the functions, would keep only the hash codes and get the name, get the address of the functions using the shell codes. But take a look, after the parsing the export table of the files, the founding function, it would be the name of the function would be load. By the way, here we would need to implement some brute forcing because the hash was not typical. It's not the typical name for the Windows API, right? It's a custom name from the next stage. It names load with a capital L. But with the dictionary, you could brute force and get the right shell code for it. The start of our load function gets 2 arguments. It's a very last line over there. I actually don't know why, because we got the next stage, and arguments was not really in use, but they keep the ASCII string with ASCII string Dave and use it as an argument for our load function. Don't know why, maybe in some other next stage it would be really in use, but in the samples we observe this Dave string just skipped. Some I like natural language artifacts, in this case it was Dave, and a constant for maybe the length of the first ASCII string. Dave we just use for ASCII chars. This is it. When you decrypt the shell code from the event data source, KMS, you would get some launcher of the next stage. Okay, I think enough from this part of the attack. I consider, once again, I started from it because I consider it the most innovative part, but many other models exist, so I promise you the broad view of the campaign. Let us take a look at all the campaign of the actor who implement such brand new techniques. What we have there? Actually, a non-typical thing was the usage over simultaneously of 2 commercial tool sets, I could say. For sure, familiar to you, Cobalt Strike was in use. It's just visible. It was a Cobalt Strike models. But I also expect another second commercial tool set was a Silent Break. Don't mind the name, but I'm not sure it's nowadays it's a proper name. It was a company bought by another company, whatever. But why I use it on GitHub, the repository still got that name. And in this repository, we still have the very old version of the model named throwback. And we see this throwback.dll, all this usage of encryption, same encryption algorithm in the models during this campaign. So I'm quite sure we are looking on some code to the guys who get the access to the same source code data. That's why I could think about the silence break. Another tool, the commercial tool of the company, it's called Slingshot, and also we observe original names of the libraries like a Slingshot DLL and as well Monolith DLL. So this commercial tool set somewhere around. Okay, it's a commercial tool set. To the full some security solutions, they decide to use some more esoteric compilers than C or C++. They use NIM and Go, and we have to understand next models, we have to fight with droppers in such newer languages. Okay, we successfully did it. Also, some library was compiled in an environment, in a MinGV environment with a GCC compiler. So you see Microsoft C compiler, GCC under Windows, NIM, Go, quite a number of compiles they're trying to use, but I consider it just an anti-detection measures, nothing more actually. I would show you the code. An interesting part is the last stages, they actually use two different Trojans, and I promised to give you the ideas why. If you have such a remote administration tool, seems like one is enough, right? For them, they use one for the local area network in a passive mode. I suppose it was for the lateral movement. So to make a foothold inside the LAN of the victim, they use based on the named pipes version of the Trojan, and HTTP version could go to the external C2, and it's a normal Trojan to communicate with a real control server. And the command set is completely different. Okay, this is the stages, and let's describe it one by one. Besides the commercial tool set, they also, it's not the first time, the manufacturers just grab the publicly available GitHub repository, in this case Blackbone. And Blackbone we observed before, used in the campaign, when the driver want to inject some code into the legit system process, Blackbone could be used. Once again, you could easily just git clone, check the code, add some part of the code needed for the campaign, compile it, and try to deploy it on the targets. In this case, Blackbone was also the case. You see, two commercial tool sets was seems like not enough, so it's like an integration process of the different tool sets. And later on, to my experience, I observe more and more usage of some code snippets from the GitHub, because why not? Why not? It's they could avoid attribution, right? They could fulfill the task with the already made code, not invest in coding. So maybe not so bad idea for the manufacturers. Okay, why I think Blackbone was in use? For sure, it's not a strings. Take a look. For those who met Blackbone in the wild, maybe quite a familiar stuff to you. One of the technique was the DLL side loading, as usual. They take the legit file verfault.dll or .exe. Verfault.exe under Windows it's an error handling, right? So error handling is part of the operating system. They copy it to separate directory, actually with a scheduled task directory, and put DLL with a very specific name, so it's just a very familiar search order hijacking. And they don't want to the verfault.exe continue its execution after the mapping the malicious DLL into memory. They need to patch the entry point of the legit exe file. This is it. So very typical Blackbone approach. Just put move racks, jump racks, and their own some own function. In this case, I name it wait and exit, wait for the thread from the DLL, and gracefully exit the exe process, main process verfault with a success code. Okay, that's why I consider Blackbone over there not the only sign, but one of the signs, just a patching of entry point of legit exe. Regarding anti-detection, besides, we already mentioned several approach. It's several compilers, whitelisted launcher. I didn't mention so far digital certificate. Typically, such an actors try to steal digital certificate from some vendor and signed for files of the campaign. It was in this case, but I'm not sure certificate was stored. When I tried to obtain legitimate normal files with the same digital certificate, I actually failed. Maybe just our visibility, maybe not. It seems like with this digital certificate, only malicious files were signed. So I suppose maybe it was obtained, it was bought only for the campaign, maybe not stealed from some legit software company. And also, I would describe it on the next slide in the details. Seems like the actor loves, you see, they adore event logs. They use it a lot, put shell code there, but they love only their own event logging. They don't want to be logged by the operating system mechanism. That's why several functions from the normal mechanism of logging of operating system, they would patch it. They would patch on the level of the NTDLL, DLL, the lowest level on user space they could obtain, so no kernel component this time, and they would just take in the memory of their process NTDLL, DLL address of these functions and patch it, as usual, with some just empty, return 0. So all good, returning, no logs appeared in your event logs viewer. And also, let me emphasize the very last part regarding the C2 name. Seems like those guys did their homework well. They make initial recon, understand which actually DLP system was on board in this corporate environment, understand the name, and register the web domain with a very similar name of this legit system in the environment. So the traffic, which some, I don't know, blue teamers could observe in the precious Wireshark, would be to the some domain which name is completely related to the DLP, and they could think maybe, maybe not, oh, it's just alleged traffic which our information system generate, not a malware. Also, interesting idea, I suppose. Okay, I propose regarding the patching. Actually, also what I want to emphasize here, it's MCI patching. On the slides, you would see patching of the function relating to the logs, ETW prefix. But MCI patching, as far as I know nowadays, it even exists in a Metasploit framework. So I would consider it as already common techniques for the malefactors and wouldn't stop as in details as I provide details regarding the binary part of the event logs. Not the first time I met patching of MCI functions. So, regarding Go, who already reversing the Go models? Did you like it? me neither. Me neither. I thought Ivan also loves, I know, the Go reversing, but this time, all what Go is doing besides the patching, it's just the decrypt next stage. What I need to obtain here, I need to obtain all this quite a painful task, all this part of the code. It was 1,000 of them. I need to write some script to put it all together, decrypt it with decode with the base 64 as usual, decrypt it with the IS, and get the next stage. Nothing more. Interesting part on the Go level, it's the heavily usage of the syscalls library. Actually, it was even back then, was a little surprise for me. I'm familiar with the syscall mechanism under Linux, right? But it's under Windows. It exists. It's very version dependent, but syscalls also exist. And if on the level of Go language use syscall library, it would be a lot of syscalls over there, but it's all the codes are publicly available, and you could understand which WinNT DLL function is called using this syscall. They decide to use this library. So on this wrapper, need to combine and decrypt. Successfully solved. And a little bit details about the patching, one more library, like library, Go library, I mean, with some lazy taking the address of the API functions and put the empty functions instead of the real ones in a memory of this process of the default DLL. Okay, if they don't want to any event logs besides their own, maybe normal decision. Enough for the esoteric compilers. If you would if you have some question regarding Go or NIM, you would ask. And now I want to spend some time on the last stage. Last stages, why two of them and what was interesting inside. So I really love when manufacturers on some level save the version of the malware. For the some targeted malware, I even keep my own dictionary. Oh, now the version 1.7.2 arrived. Nice, nice. Before I have only 1.611. Let's take a look what's new. In this case, in a traffic, so generated in the initial beacon, for one of the Trojans, version exists. So also nice to have it. I wouldn't repeat all from the slides, just some interesting points over there for me. I love the randomization all the time. This point, randomization over with sleep time. To my understanding, it also try and make the life of incident responder harder. For example, not to correlate the initial infection date and first beaconing date. Some randomization is a good idea for the making correlating of different events harder. But with quite a strange randomization, for example, sleep time, they would take from configuration data. And after it, multiply to some random value from 0.9 to 1.1. Is it so random? So the difference would be quite similar values, right? So the difference is only about 20%, around 20%, right? Nothing more. But anyway, they implement it. And also I love in a LAN version of Trojan based on named pipes, it's a getting of the how long user is inactive. They don't want to be too active in a time when user is typing something. So maybe operators just check 5 to 2 hours inactive. Maybe it's time to do something on this server. Seems like nobody is watching now the server. Time to send some comments over there. All other, I suppose, one more thing maybe here, they adore injection, really adore injection. They obsess it not only with the Windows event logs, but also to this DLP process, to LSS process, whatever, inject their code. They have a separated command in both Trojans to inject their code, whatever. They could use process ID to inject, process name. They really adore this stuff. And some regarding the command system. Here, it's a command system, short-term command system from the Trojan, but please keep in mind, it looks like they have some repository like a constructor and could combine the media, which Trojan would use, named pipes or HTTP, and which command system it would use. So they could simultaneously, for example, this in the case of samples, we could observe it was brought to the HTTP Trojan, but we also saw named pipe Trojan with a similar command system. Interesting part here, the commands you could see, quite typical for any Trojan. I love during the fingerprinting, they would get mesh and GUID. Maybe when you build some unique ID for the user, not a bad idea to use mesh and GUID as well. And also, let me briefly describe the C2, one more randomization. They would keep the list of control server, and in any communication, they would randomly choose the C2 from the list. So if C2 is alive, they would work with this server. Next time, it could be another alive server from the list. Nice, I suppose. Encryption is a throwback-like, already described in the previous slides. Command system you see here. So, next Trojan. Next Trojan, that one of the original file name was a monolith DLL. We saw it in the table. So I prefer to call all this activity monolith because all the other names I observed here was just the name of the toolset, commercial or not commercial. And take a look. In this case, the common system far more profound. Not all of them is here, otherwise it would be too long list. And as one more want to emphasize, such a HTTP version with the same profound common system also exists. So they could construct their Trojan as they want. So, time seems like we're almost out of time. Let me briefly sum up what we get through this presentation. I provide the new, at least be considered new and innovative technique of keeping encrypted shell code into the Windows event logs. We show you the dropper, how to write to the event logs and how to read, so some launcher, what was kept inside the shell code, and all other modules around it are auxiliary for the anti-detection modules and last stages, which would be active as a result of all this campaign. So I hope you as researchers would benefit with such a modern type of the techniques in the current targeted malware. I'm really ready for any questions, and I really hope it would be any. Please, fire away. Questions time.
Hello.
How do they execute the shell code? Because even if the shell code is fileless or stored in the event and registry, it's going to get detected eventually with, for example, create remote thread. At least that's what I have experienced in Defender, because when you execute that in user land, I think the kernel mode scans the buffer and the cobalt strike is detected basically. So I'm wondering why all these threat actors are using like detected shell code.
Sorry, I'm not sure I fully understand the question. Sure, it was quite loud over there. If you, for sure, I provide on a slide with the shell code, it was not full of it, right? It was only part of it to show it's quite a familiar techniques for the shell code. Could you please repeat the main part of the question?
Yeah. So how do they execute the shell code without being caught? Because cobalt strike is detected, right? Because I'm pretty yeah.
Cobalt is detected for sure. Yes, it's all the last stages. As a result, they have different branches of execution. Some of them include cobalt, some of them did not. The last stages, I suppose, we already detected heuristically before, but not all, seems maybe not all the host of the interest has a security product installed. So we detected it, true. So the last stages in memory, but to make all these steps back to the very initial infection, not all of the models were detected just because some of them do nothing wrong, actually, right? Launch do nothing wrong, it just launch something. Okay. So if I get your question right, so I hope I answered.
Yeah, if I understand this correctly, you mean that the last stage was detected, but the initial stages were not detected. Like based on heuristics, I guess you detected that.
How we combine it all together, all these techniques? You see, we are using telemetry to see if it's all always connected to each other. Hope I answered, yeah.
Are they using any shellcode generators like Donut or something? Or are they using custom shellcode generators?
Sorry, once again, about the shellcode?
Shellcode generators. Are they using shellcode generators like Donut or like shellcode reflective DLL injection like SRDI, the project?
Shellcode was just the auxiliary part, which parsed another delivered data to map it into memory, and run corresponding function using the hash of this function. In this case, it name load with two arguments, Dave and 4. I hope sometimes we would get the next stages for which these arguments would be meaningful, but in this case, it just skipped. Okay, Dave and length of the Dave. So it's auxiliary. As you know, to my experience, shellcodes rarely execute the final task, right? It could decrypt something, find something, inject something. It's no reason to build huge functionality of live stager in the form of shellcode, I suppose. Mostly it would be injected PE anyway.
Thank you.
Thanks for the questions.
Anyone else question?
More questions? Good, good.
More out of curiosity, you said that they were digitally signed payload. So who was the root signer? Like where did they get the
Root
certificates
signing, have to check, but it was something normal, like a Commodore, someone normal, which I know the name, but I sorry don't have it in my mind here.
Okay.
Uh-huh.
And the signer did not have information about the organization that requested
It is, but it was just, it was on a slide, I suppose, so some name I never heard before, like, I don't know, just security, whatever, and this, the main, main idea here, using this certificate serial, I wasn't able to find any legit files. So I suppose the name of the organization is not that crucial. If you Google it, nothing. It was a Fast Invest in this case of this campaign. So some Fast Invest exist, but I'm not sure it's related because the region is too different. So target of the campaign and this Fast Invest I could Google, it's not related at all because of the very different regions. But I suppose the main part of certificate which you could use, it's not the name of the organization, but the unique serial. And using unique serial, I didn't observe any legit application actually. Okay. I suppose they just bought, provide to the certificate authority maybe with fake name, get the certificate, sign till the certificate would be blacklisted. I see the technique like this, my understanding of the technique.
The part I found interesting is that for files, they got this certificate for signing, but for C2 communication, it was still on HTTP, not using TLS with, let's say.
It was about the files, yes. It's not about the server, not about SSL, about the file signed by digital certificate.
No, I got that. Too. Yeah. So anyway, thank you.
Thanks. Actually, in several campaigns, we observe some certificates. Sometimes it's legit. We just let know the vendor, seems like the certificate's compromised, please revoke it. So it happens. So it seems like such a software campaigns as a target, could be the target because as owners of some whitelisted certificates. Seems like questions are over. I'm here, not running anywhere. Please ping me out of the stage. Thanks, many thanks.